Hi folks, we're going to take a look at page 140, number 17b. Okay, so here they're asking us to find the equation of the tangent to this function y equals 2x squared plus 3 that passes through the point 2, 7. Okay, so first and foremost, the equation of the tangent, meaning we're looking for the equation of a line that is tangent to this curve, and that line also passes through to negative 7. Okay. So, since we need to find the equation of a line, we need a point and the slope. Okay, so the point is 2, negative 7. We know it passes through that point there. Now, since this line is tangent to the curve, the slope can be gotten by finding the derivative of this function. So in this case here, the derivative of this function is, well, 2 times derivative of x squared is 2x. So 2 times 2x is 4x. Okay. And then plus the derivative of 0 is 3. Okay. Unfortunately, what we don't know is at what point this line is tangent to the curve. Okay, so our slope here is variable. Problem is if I try to use y equals mx plus b, okay, well, I have an x and y value that are on this line, since the line passes through 2, negative 7. Okay, but unfortunately, I don't have the the y-intercept, and I don't have an exact value for the slope, so I can't solve this equation as I don't have enough information to end up with just one variable. Okay, so let's take a look at an alternative approach. Okay, we know that 2, negative 7 is on this line, on the tangent, but since it's tangent to this curve, we know the tangent line has to touch that curve at a particular point. Okay, so we'll call this point 1. The second point that's also on this tangent line is, well, whatever x value it touches the tangent line, and of course its y value, but its y value is just given by 2x squared plus 3. Okay, so this is the given point that the tangent passes through, and this represents a point on the curve. Okay, and it's going to represent the point where the tangent touches the curve. Okay, so just to be sure, this is point on curve. Okay, where tangent meets. Okay. Now, just in case anybody thought that 2, negative 7 was on the curve, okay, let's just be sure that if I stick in x equals 2 and I calculate y, I'm not going to get negative 7. Okay, so be sure that you understand that 2, negative 7 is not on the curve, it's only on the tangent line. This point here represents the point that is both on the tangent and on the curve. Okay, but now that I have these 2 points, I can come up with an equation for the slope. Okay, the slope will just be y2 minus y1, so 2x squared plus 3 minus negative 7, divided by x2 minus x1, so x minus 2. So here the slope is given by 2x squared, 3 plus 7 is 10, okay, over x minus 2. But I know the form that the slope must take. Since it's tangent to y equals 2x squared plus 3, I know the slope must take on the form 4x. Okay, and what we've managed to do here is to create an equation that has only one unknown. Okay, so the right-hand side we got by using the slope formula, using the given point, and this point on the curve, which is also on the tangent. Okay, and then we got the slope itself by finding the derivative of this function. Okay, and we ended up with an equation we can now solve. And this is a fairly straightforward rational equation, so I'm just going to multiply x minus 2 to the left-hand side. So we have 4x times x minus 2 equals 2x squared plus 10. Okay, this 4x squared minus 8x. Okay, and here let's bring everything to the left-hand side. So here we're left with 2x squared, okay, minus 8x, and then minus 10 equals 0. Okay, simplify that by dividing both sides by 2, so I'm left with x squared minus 4x minus 5 equals 0, and luckily we get a nice factorable expression on the left-hand side. Okay, so this factors to x minus 5 times x plus 1. Okay, so that means x is equal to 5, or x is equal to negative 1. Okay, so let's make sure we understand what we solve for. These are the x values where the tangent is going to pass through 2, negative 7. Okay, so first thing we see is that there's more than one solution. Okay, now what we're looking for are the equations of the lines. Okay, so we still have quite a bit more work to do. So since I need to determine the equations of lines, I know they both pass through 2, negative 7. Okay, and I know that the slopes are given by 4x. So now I can use these x values that I found to find the two possible slopes. So slope 1 will be 4 times 5. Oops, I'll show here. Slope, remember, is 4x. So the first possible slope will be 4 times 5 is 20. And then the second possible slope is 4 times negative 1, negative 4. Okay, and they both pass through 2, negative 7. So let's calculate the equations. Okay, so use y equals mx plus b. So y, negative 7, is equal to mx plus b. So now we can solve for b. So here negative 7 minus 40, so negative 47. So one of our tangents will have the equation y equals 20x minus 47. And now let's do the second one. So y equals mx plus b. And so here this is negative 8. So here b is equal to negative 7 plus 8, which is equal to 1. Okay, so the second equation is y equals negative 4x plus 1. Okay, and there we have it. So let's do a recap. Okay, first thing is to realize that we had a point on the tangent line, and in order to find the slope, we took the derivative of the function. Okay, working with y equals mx plus b didn't work directly because there were too many unknowns left, so we used our slope formula to determine an equation which we could solve. Okay, so again, there's a similar question to this on the homework. Please make sure you can do this type of question here. Okay.